Continuing where we left off. So far we've been discussing data structures in the last few videos. Um, a lot of them to deal with a list of data and how you can access it through different libraries. Um, so far I think we got arrays, vectors, lists, stacks, queries, dequeries, sets, maps. Maps are kind of unique though because you can add a keyword to the elements in the list, where any of these others and stuff, they have a index number. So, and then we went through iterators, and we're still kind of working through iterators. Let's continue there. In the iterators part and stuff, we left off at algorithms. I've never dealt with algorithms yet, so this will be new for me. Another important feature of iterators is that they are used with different algorithm functions such as sort and find, found in algorithm library to sort and search for elements in data structures. For example, the sort function takes iterators as parameters to sort elements in data structures from the beginning to the end. Okay, typically return by beginning or end. So you would sort using beginning or end to go through the parameter from the front or the back. Okay, in this example below, the elements are sorted alphabetically since they are strings. Okay, so got an example here. Kind of got a little bit of the same stuff here already. I'm going to get rid of this for loop though, because we're going to end up rewriting it. So let's go ahead and get rid of this. Let's add in our algorithms library here. So this is something new to me, so I'm going to be completely learning this, exploring this, discovering this. Still got the same vector set up with the same elements in it. We're going to add down here though. Clean this up a little bit. There we go. So we got a comment first. Sort. Sort cars in alphabetical order. So sort. I bet that needs standard. Oops. Cars dot beginning. Or begin to the end. It looks like cars dot end parentheses. Declare that. So it looks like it's going to sort the cars from the beginning to the end. And then we got a for loop here. Print. So even though it's sorting them, if we want to see that sorted list, looks like we're going to have to print it up. So we need to create a for loop. Get this typed in here properly. There we go. A for loop for printing them out after they're sorted. So here's our for loop, standard out, car, and a new line after. Okay, and save it. So yes, we still got everything the same. The only difference is we're adding an algorithm library right here, which again, these things can be made yourself, because that's all libraries are, is something somebody else has created. These things were created a long time ago. Using simple code like this, it may be more complicated than this, but not so simple. But in this case and stuff, we're going to basically resort this right here in alphabetical order. I've got a little bit more than what they have on their list. I'm actually going to end up adding, I think, a few more to it. We got 5 now. Let's go ahead and add in Honda, Toyota, and VW. Okay. All right. So now we can save it, run the program, and this should come up alphabetical order from the alphabetical order from the sort list created from the algorithm library, and then print it up with the for loop right here, printing each car. Let's run this. Got BMW, Ford, Honda, Mazda. Yep, all in alphabetical order. 2 BMWs because I got 2 BMWs in the list. So moving on to the next part here, and in this example, the elements are sorted numerically since they are integers. So we got to recreate our vector here because we're changing it from strings to numbers. This is how you would change that. This is pretty much the only way. And then change our name for it. It's going to be numbers. And then change our numbers, or change our elements here. So 1, 7, 3. Guess it really doesn't matter what they are. The idea is to put them, just get them in there. 5, 9, 2. Oops. 2, and we'll make up a couple more numbers here. There we go. So now we got a new vector with all integers, naming it numbers. We're going to have to adjust this sort right here to where it includes the name for our vector. Instead of cars, it'll be numbers. And then change cars here to numbers as well. Go ahead and change this to number. All right. And that's pretty much the gist of it right there. We'll go ahead and save it right there. Get rid of that. Do we have that spelled wrong? No. Oh, string, yeah. So this is no longer a string, this is actually an int. Now we can save it. Now we can run it, we won't have any problems. It'll sort all these numbers from beginning to end. So it should be lowest number first, highest number last. Moving on to reverse the order, you can write R begin, R end instead of begin. So if we wanted to sort it in the opposite direction to the highest numbers first, we just add R. So reverse begin, reverse end. I imagine, I'll run this real quick. Yeah. I imagine you can also do it a different way too. So instead of having reverse begin, you could probably put end right there, as well as begin right here, and it'll sort it from the end to the beginning. Let's see what happens here. Nothing. Apparently you can't do it that way. Okay, so you have to sort it from the beginning to the end. And then reverse the order. So apparently you can't do it this way. You have to do beginning to end first. Interesting. Good to know. Moving on. Now we're going to get into the details of this algorithm library. We kind of seen a little bit of how it worked and stuff, and this time we're going to get more into maybe the details. So in the previous chapter, you learned that data structures like vector lists, etc., are used to store and organize data. Algorithms are used to solve problems by sorting, searching, and manipulating data structures. So we've only so far done the sorting part. We got searching and manipulating. And I'm sure there's more to sorting than what we've done, but for now, like I said, we're just kind of discovering this. So the algorithm library provides many useful functions to perform these tasks with iterators. To use these functions, you must include the algorithm header, which we've already gotten up there. We've already seen this right here part. So sorting algorithm, which we've already seen. To sort elements and data structures, you use the sort function, which we've already done that. We already did the example for that. We even learned that we cannot have begin and end switched. It's going to be begin to end. If it's possible to switch them, I'm not sure how, because obviously it didn't work when I tried doing it. Okay, by default, the elements are sorted in ascending order, and if you want to reverse it, you would put the R in there. So in this example above, the elements are sorted alphabetical order, which we did that already. Sorry. And then if we had a vector of integers, they would be sorted numerically, which we did that one already, which is the example we have sitting up here already. To reverse it, we've already done that. So this is kind of going over the same stuff that was literally just in the last section. Only sort specific elements you would write like this. So if you, I guess, sort numbers numerically starting from the fourth element, only sort 5, 9, and 2. Okay, so this is something else we kind of uh, did before, where we were indexing a certain one from the beginning or a certain one from the end. If it's from the beginning, you add to it. If it's from the end, you have to subtract from it. And you got a comment right here, so sort numbers numerically starting from the fourth element. Basically only doing 5, 9, and 2. But in this case and stuff, we won't be just doing 5, 9, 2 since I've added 2 more in there. But the way you would do that would be to add 3. Save it, run it, and then you're going to skip the first 3. It didn't skip the first 3. Oh, no, it didn't skip the first 3. It sorted it from after the first 3. So the first 3 stayed the same. In this case, 1, 7, 3, and then after that it started sorting them out. So it still printed up everything. It doesn't show anything being printed up in this. Let's see here. Yeah, it doesn't show. Yeah, it does. It does show it. Okay. It just doesn't show the printing part there, the output. Okay, it's clear out. Searching algorithm. To search for a specific element in a vector, you can use the find function. It takes 3 parameters, start iterator and iterator value, where value is the value to search for. Search for the number 3 in numbers. Okay, so to search for a specific one, this is how we would do it. We need to erase that. We're still going to have all this in there, but we're going to add some parentheses. We're going to add one here. Oh, no, we're not going to add any parentheses. We're just going to have a comma to search for 3. Is it the number 3 or is that search for? Okay, so there is a comment here. I'm going to go ahead and add that comment in as well. The comment shows that we're actually searching for number 3. So if you're searching for a specific car, specific person, specific whatever, this is pretty much how you would do it. You would put whatever you're searching for at the end right here, and then it has standard sort, but in this case we're not sorting, we're finding. So auto it find. Now if I was, oh, I forgot something there. There we go. So if my short-term memory worked real well, I would remember already how to rewrite that, and I think I can. But yes, this is the short form of writing it for the iterator. Control save, run it, and then we're just searching for the number 3. Oh, my bad. We need to take this for loop out in the comment. Standard output it, and let's see what that does there. What does that seem to be a problem? Let's run that and see what that does. Okay, so it gives us a problem, but let's see if I think we may have to. There we go. Yeah, dereference it, save, run, and it searches for 3 and finds 3. Doesn't tell us anything about 3 though. So maybe that's just something a user can do, to where you set this as a variable, and then you ask a user what you're searching for, and then it finds it, puts it in this location right there, and finds it in the list. But yeah, the other way of writing this, if I'm not mistaken, let's see if I could do it. See if I remember how to do it. Standard uh, vector. This is integer iterator. Is it. Nope. Let's go back up here and look. Doesn't hurt to look. Yeah, I got it all. Oh, okay, you don't need this. That's what was messing up. Don't need that. And then we can basically just, should be able to do that right there. Control save. We should get the same outcome. I was close. I had a assignment operator in there. Go back down to here. Go back down to the find search area. Yep, right there. Okay, now to search for the first element that is greater than a specific value, you can use the upper bound function. Okay, so that's a new one right there. Upper bound function. So we got a new example here, same vector, sort. So we're going to clear this out right here. Delete that, sort. Clear this out because we don't need that anymore. Go ahead and take this comment out as well. Don't need this anymore because we're going to change this. We do have a comment here though. Sort the vector in ascending order. Okay, so we got that there. We don't need to, we're not searching for anything, so we don't need that in there. And then take this out right here, add a comment, and then an output. Find the first value that is greater than 5 in the sorted vector. So auto it assigned upper, which we haven't discussed upper bound yet, so not sure exactly what that is. Numbers begin, numbers end. So let's take this right here. Put that in there, comma, 5, oops, in that, and then spell this right. And then we need to output it. So standard out, dereference it, save, run. And it searches for 7. So what is it searching for here? So let's see here. We got the sort right here from beginning to end. So it's going to sort it out. And then we're going to find what's it doing against. You search for the first element that is greater than a specific value. So you're searching for the first element that is greater than, so it's going to sort it all first in order. And then it's going to search for the first value that's after 5, which we got 5 in there. So it's actually searching for 7, which is why we get 7 down here in the output. Okay, so yeah, this is all very new to me. So the upper bound function is typically used to sort data structures. That's why we first sort the vector in the example above. To find the smallest element in a vector, use the min element function. To find the smallest element in a vector, use min element. So what if it's a string though? So I don't know how to do it if it was a string, but we got a new function here. We're going to change this upper bound to minimum element for this next example. Min underscore element. And that will give us the minimum. So save it, run it, and we get something's wrong. Let's try it one more time. Nope. What is wrong here? Oh, we got the 5 right here. We don't need this. There we go. Because we're not searching for something. It won't find it and stuff if it's not the minimum. The minimum is 1. It's trying to search for something, the minimum after 5, I guess. And that's not possible, I guess. To find the max function, so we would do the same thing, but just switch that to max, and it will tell us what the max is, which would be 90. Modifying algorithms to copy elements from one vector to another, you can use the copy function. Okay, so we're going to keep this right here. And we're going to change this. We're going to add another one to it. Okay, so let's create a new one here. I've got a comment first. Create a vector called copy numbers that should store 6 integers. Unfortunately, ours is not 6 integers, so that won't work. Ours is 8, so we're going to change this to 8. And then we're going to write the code for that. So standard vector integer, oops, this is in angled brackets, int copy numbers. This is the name of our vector right here. It shows 6, but we're going to do 8 because we actually got 8 in ours. So we're just declaring that, and we're changing pretty much. Do we need that part? Yes, but no. We're going to change the comment here to copy elements from numbers to copied numbers. And then we're going to change this from sort to copy. I'm pretty sure copy is probably going to be done the same way as that. Nope, actually it's not. See, trying to get used to which one needs standard and which one doesn't. Okay, so we got beginning to end, but we're going to have to add one more thing here at the end of this, which is the copy function. Numbers dot begin parentheses And that is closed off, right? Yep, okay. So that's all it shows us. We don't need this anymore. We don't need any of this anymore. I guess we do need that. Okay, I put an S at the end of that. Doesn't need to be an S. So what did I just have there? Auto it is do we want to be able to print whatever this is? Copied numbers. That's not right. What did I just have there? I had that, but we weren't doing minimum or max anymore, so copied numbers. Okay, so yeah, maybe we actually don't need this at all. Instead, what we would need is to print up the vector right here. Copied numbers. 8. Okay, well, it's not really showing us how to do that, so let's go into the try mode here. Find the largest number. Nope, that's not the one we were on. Copy in. There we go. So we would need a loop, is what we would need. I don't know why I didn't think of that. We need a loop. Okay, so we don't need this. We need a loop. Oops. So for int number num copied numbers. I always keep putting numbers in there instead of number. Probably because I have numbers in there and I just didn't put it in there. So let's just make it simple, so I stopped doing that. Yes. Yes. And then you do the output. Standard output num. Oops. Yeah. Num. And then space. Instead of going down the screen, we'll go across the screen. And that should do it. Yep, there you go. So we changed everything. We took everything out of this vector right here and put it into a new vector name. And then by doing the copy from beginning to end into this right here, we didn't sort it this time, but if we wanted to sort it, we could add that into it too with the standard sort numbers. Sorry, copied numbers, because it's no longer dot begin parentheses comma copied numbers dot end. So remembering that and actually make sure it works properly is a good thing, because that means it's stuck for that long anyways. So run this again and it resorts it. So first of all, we have the first vector, then we create the second vector, just declaring it with 8 in it. And then we're taking that entire list and copying it. So actually, I think both lists are going to exist. In fact, we got this right here. And once that's done, standard out new line. Oops. and then another for loop right here, for int, what's this one? That's numbers. So let's put C, delete numbers, copied numbers, add that to here, C, delete numbers, and then put num, numbers, and then put our curly brackets in there and pretty much outputting this one too. Oops. So now we have two lists. Both of them are identical, but each one of them have a different name for the vectors. So we still have this one right here. Now we have this one right here, and we were pretty much copying one to the other, sorting them from lowest to highest, and then for both vectors we are outputting both of them. Simple stuff, right? Not really, not for a beginner, anyways. But yeah, it just tells me that I'm getting used to doing this, which is a good thing. Okay, so moving on to fill all elements in a vector with a value, you can use the fill function. Fill all elements in the numbers vector with the value 35. So, so we've already gotten this part of it down, but we have 8 instead. Now we're going to fill it with the value of 35. So actually, I think we're going to add 35 to it. I think that's what it's getting at. So we're going to put this in the bottom and then run another loop. So fill, parentheses, numbers, and that may need the standard in front of it. Begin, comma, numbers. Yeah, because no, it won't reprint it. It'll print the original and stuff and just add it to it. So I was thinking it would do the same thing for both, but I guess if you want to add one to another one and then have a copy, you would do that higher up in the program code. That way this number would get copied too, but you would have to change the number of elements in it prior to adding one. 35. Oops. 35 is what they have for the example. In that, now, like I said, fill, I'm pretty sure is going to need standard in front of it. And then my spelling issues be fixed. Okay, and then we create another for loop. All right, for int. Actually, before we could do that, we need to go ahead and create a new line. Standard output, new line, and then for int number, numbers, and curly brackets, standard out num with a space in between both, and save. Run. Now we should have 3 lines. Okay, so it doesn't actually add it. It just changes every single one of the values to 35. So that's what that does. Change them all to 35. Interesting. To fill elements in the numbers vector with the value 35. And these ain't considered keys since this is a map, but I imagine you can do probably the same thing with keys. I don't know. Haven't tried it yet, but that's the end of this section right here. There's more on it on algorithms. but we're not to that point right now. We're just trying to get everything discovered as far as what W3 Schools has to offer once we get through W3 Schools, which we're just about there. We got namespace projects, certifications, which I'll probably skip over certifications. I'll probably glance at it, but I may not do a video on it because you can't even get the certifications without actually paying for the services from W3 Schools. So if you want your certifications, most likely you're going to have to pay for them from W3 Schools, which is a great way to support the website, especially since if you just use the website to learn this stuff and you're trying to get certified for a job, sort of thing. And then we got how to, and then we got the references and examples. But the references and examples we're not going to go through because the references just kind of give us all the keywords. Probably, I'm not sure. We may take a quick glance at that, but it's not going to be a long video if I do, even if I share it. Most likely after we get done with how to or finish up with this right here, we're probably going to jump into my other source, which is much more detailed than what this is. Anyways, I think I'm going to end the video right there. Um, like normal, if you have any questions, comments, or anything you want to correct something I've said, leave it in the comments. It's fine by me. I do try to get to the comments. If you like the video, click the like button. Otherwise, I will see you in the next video.